at question number 2 on the non-calculator part of the performance-based assessment for Algebra 1. It is the 9th question overall, and it says this: at the beginning of an experiment, the number of bacteria in a colony was counted at time t equals 0. The number of bacteria in the colony t minutes after the initial count is modeled by the function b of t equals 4 times 2 to the t power. What is the average rate of change in the number of bacteria for the first 5 minutes of the experiment? Well, first of all, if I look at this, again, what they've told me is that this function shows the number of bacteria, okay? The number of bacteria is equal to 4 times 2 to the t power, where t is the number of minutes, it looks like. T minutes after. So if you think about what's happening here, let me just make a quick little table of values. A time column, and then a number of bacteria, total bacteria column, and the expression for this function is 4 times 2 to the t power. This is an exponential equation, and if I think about it times 0, 4 times 2 to the 0 power. Okay, at times 0, if you know what an exponent of 0 means, then you know 2 to the 0 power is equal to 1. And so 4 times 2 to the 0 power is 4. You can use a calculator when you're taking this test. The calculator option is up here in this menu. When we do the online version of this practice test, you can't have access to the TI-84, but in class you should be able to practice using one to do these calculations if you need assistance there. So in other words, at time 0, there are 4 bacteria. And just to see what happens here, at 1 second, and 2, 3, 4, all the way to 5 seconds into this, if we take 4 times 2 to the first, we get 8. 4 times 2 to the second is 16. 4 times 2 to the third is 32. 4 times 2 to the fourth is 64. And 4 times 2 to the 5th power is 128 bacteria. So we can see that it started off growing at a kind of a slow amount, a smaller amount, but then it increased rapidly. So at time 0, we start with a certain amount, and it's increasing, but at some point, because it's an exponential function, okay, it begins to rapidly grow. And so if we look at from time 0 to time 5 seconds, they want to know what's the average rate of change if we just have an average, make a straight line. So we're going to find the slope of the line that connects the first point, which is at time 0. So my ordered pair is going to be 0, 4 at time 0. And at time 5 seconds, 128 bacteria would be my total. Okay, in my class, to find slope, we practiced using this formula, y2 minus y1 over x2 minus x1. So if we're working with these two ordered pairs, 0, 4, and 5, 128, we can take y2 minus y1 and x2 minus x1, and we can find the slope, or the rate of change, is 128 minus 4 over 5 minus 0. And so that gives us 124 over 5. Now remember, 128 minus 4, that was the number of bacteria from time 0 to time 5 seconds. So 124 is a number of bacteria, and 5 is a number of seconds. In other words, the average rate of change is 124 bacteria every 5 seconds. If we divide that 124 divided by 5, we get 24.8 bacteria per second. So in our drop-down menus, we would choose 24.8. Says the average rate of change in the number of bacteria for the first 5 minutes of the experiment is 24.8 bacteria per, oh, it's not seconds, is it? It's minutes. Bacteria per minute. Let me fix that.